For the past few years, artificial intelligence has operated like a brilliant but stubborn oracle. You type in a prompt, hit enter, and it generates a text response, an image, or a block of code. But it only ever works when you actively push it. That creates a massive execution bottleneck. A chatbot can easily generate a complex recipe, write a research essay, or map out a 10-day travel itinerary. But to actually make any of that happen, a human user still has to manually click the buttons, buy the ingredients, copy the text, and book the flights. Google's recent Keynote revealed a direct solution to that bottleneck. They are pivoting to what they call the Agentic era, moving away from software that helps us write and instead deploying systems that autonomously take action in the background. Instead of typing, "Give me a vacation itinerary," and reading the result, you can give a directive like, "Book the trip, buy the gear, and adjust my calendar." The system then goes off and handles the logistics on its own. A digital proxy acting on your behalf necessitates a departure from standard software design. Moving from passive text prediction to autonomous execution requires building a specific technological anatomy from the ground up. The core of this new structure is the brain, powered by models like Gemini Omni and 3.5 Flash. Rather than just guessing the next word in a sequence, these advanced models are designed to simulate real-world physics and process vast amounts of information continuously without slowing down. But a brain needs a way to communicate with the body. An invisible framework called Anti-Gravity 2.0 acts as the nervous system. It gives the AI a way to plan, delegate tasks, and execute actions. When fed a complex directive, it spawns asynchronous subagents, dividing the workload into parallel tasks that run simultaneously. To test the limits of this architecture, Google gave an empty anti-gravity terminal a single complex goal: build a fully functional operating system from scratch. Left completely alone for 12 hours, 93 distinct subagents worked in parallel. They wrote the code, audited their own work, caught errors, and iterated endlessly. The resulting operating system was fully capable of running the classic video game Doom. The entire autonomous development cycle consumed less than $1,000 in computing costs. When a system can break down a multi-day engineering effort and execute it independently, the traditional constraints of software development vanish. The limiting factor is no longer how fast a human engineer can type. A modern digital nervous system is incredibly powerful, but it still needs a way to grasp the physical world. The agent's hands come in the form of Gemini Spark and the Universal Cart, economic protocols that allow direct interaction with merchants. Allowing software to spend your money autonomously presents obvious risks. To maintain control, Google introduced the Agent Payments Protocol. It lets a user set strict guardrails by generating a digital mandate tied to an exact budget. Furthermore, if an agent attempts to buy a part that won't fit the items in your cart, the system deflects it and triggers a compliant pathway. To truly operate on your behalf, this anatomy requires one final layer: senses. The AI needs hardware to break out of the web browser and perceive the physical environment. That arrives this fall through new intelligent eyewear developed with Samsung and Warby Parker. These glasses act as a continuous audio and visual feed, allowing the agent to see and hear exactly what you do in real time. Because the agent shares your point of view, it can anticipate your needs. As you walk toward a familiar coffee shop, the glasses recognize the location, and the agent proactively places and pays for your usual order in the background. By finally combining these economic capabilities with wearable sensors, the concept of a traditional screen-based user interface fades away. The physical environment itself becomes the interface you use to command the software. We now have a complete anatomy: a world-simulating brain, a delegating nervous system, economic hands, and wearable senses. This structure shifts the human role within the system. Instead of manually operating individual applications, we provide high-level directives to a digital proxy that manages the technical execution 24/7. And this exact agentic infrastructure points toward a much larger horizon. DeepMind leadership clearly identifies these capabilities as the direct stepping stones to artificial general intelligence. The same anatomical framework that allows an agent to book a flight or write code can be scaled up to tackle staggering scientific complexities, simulating vast physical realities rather than just generating text. Projects like Alpha Earth are using these agents to predict catastrophic weather patterns days in advance. At Isomorphic Labs, researchers rely on them to model molecular interactions and proactively design treatments for complex diseases. A moment of wonder. These autonomous systems are moving from managing household logistics to designing molecular solutions for disease. They are becoming the infrastructure researchers use to solve physical problems previously beyond our reach.